Hello and good evening. Welcome to uh, section section 5, group 4. Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim Azami and my matrix number is DE220124. Okay, now I will be going to presenting to you about PS1A overhead line model, which is this is for part A, computation of line parameters using MATLAB. Okay, so for this video demonstration, I will show you show the design step and show how to compile run the simulation using the MATLAB. Okay, so now we're going to straightforward to proceed exercise 1, which is A here. You can see figure 1, and fortunately that this lecture already given the MATLAB code, so we're going to see if anything right or wrong, and then we're going to answer it a bit more clearly, which how each command line will output. So like here the AB input, it will ask us to input the AB formulas. So I already copy here into the editor, and then for now we're going to start this program 1. Okay, so now to enter DAB value, so we can see straight from the figure 1, which is A to B is 35, we insert here 35. Also B and C is 35, we insert here 35, and for AC is 70, so we insert here 70. So now the MATLAB calls us for geometric GMR for L, which is, if we concluded here in manual calculation, I got it 0.0444. So we're going to enter 0.0444. Then we're going to receive the inductance value. So here is 1.3802. So now he asks us to enter conductor diameter in inch. So we already have here in the question, which is the conductor have diameter of 1.345 inch. Enter, and there we go, we got the capacitance. So this is how you do using the MATLAB. Just you need to know how to make the command line, and we need to understand how to proceed the command line as you can get from the above, and then you can proceed to the MATLAB. As here we're going to take note that for the exercise 1, the inductance is 1.3802. Meanwhile, for the capacitance is 0.008 micro. Okay, that's for exercise 1. Okay, welcome back. So now we're going to do the for exercise 2, which is program 2. Here, as you can see from the figure 2. So now we're going to look at for program 2 command line. So we're going to copy this and insert it in a new script here. Then we set enter and we run. We run and we save it as program 2. Okay, as you already saved, press to clear. I guess no need to clear. Already stated. Wait, I think we need to clear first. Hold on a second. And clear. Now we're going to run back. Okay, for program 2. So enter the DAB value, which is the same also in the figure 2, 35, and then for BC value 35 and AC value also 70. Meanwhile, to enter the conductor diameter, you can see here, which is 0.977 inch. The bundle spacing is here is stated as 18 inches, and the GMR, which is geometric mean distance, no, that's for GMR, it's already stated here, 0.2924 in inches. Then we click enter and it show you the value. For inductance is 1.0588. Meanwhile, the capacitance is 0.0107. We're going to take note of this. That's for program 2. Okay, so for program T, it's going to be a little bit hard. So here we need to clear first. So let's see and clear. After clear, we're going to make a new script, and we're going to take this, all of this, and then we're going to take this, the already corrected value. Now we're going to paste it and enter, and we're going to run it. We're going to rename it as program 3. So program 3 already started. So for S11, S22, and S30, we need to insert this, which is for S1. We need to enter as a vector. So S11 is 11 meter, and for S22 is 16.5 meter, and for S33 is 12.5 meter. Then we enter. So for the row vector H12, which is here is already concluded for H12 is 7 meter, and for the H23 is where you add both of it, which is no, this is the wrong one. This is supposed to be S2 and H2 and 3, which is 6.5. And so the bundle spacing in inch is here, you can see here 18 inches. Conductor diameter, which is 1.427 inches. The GMR is 0.564 inches, and there we have it. We're going to receive the geometric GMD, GMRL, GMRC, L, and C. 0.4914, and C is 0.0232. Okay, so we're going to take note of this. I need to let you know that some of the, if you can see from exercise 1 on the program 1, we will have the same like the manual calculation, but for program 3 it become different but very small. You can see here from the MATLAB that we already done, inductance is 0.4914, but for my manual calculation we will receive the inductance as 0.450 milliH. Okay, so it's not quite the same, almost the same. This is 4491, but for me I got 0.450. So how about the capacitance? It's also the same, almost the same, but not entirely. So see here we got 0.232. Yes, 232. Meanwhile in my manual calculation, I got 0.025 microfarad. So there's a bit unsimilar, but it's still not too far the value is. Yes, that's all for me. Thank you.
Hi, Doctor. My name is Yunus Abdul Khalif. My matric number is AE2087, and tonight I will present the lab sheet, especially comparison between lab sheet answers and manual conclusion and conclusion. So let's start. In exercise 1, it appears both lab sheet answer and manual conclusion have obtained same values of the inductance and capacitance per phase per kilometer. The lab sheet answer used MATLAB to obtain the values while the manual calculation used formula and calculations directly. The lab sheet answer has also presented the conductor's radius calculation in different way by dividing the diameter by 2 times 12, while the manual calculation has divided the diameter by 2 times 12 directly. Other than that, in excess to both lab sheet answer and manual calculation has arrived at the same value for the inductance and capacitance per phase per kilometer of the given transmission line. The lab sheet answers has again used to MATLAB to obtain the values, while the manual calculation has used formula and calculation directly. The lab sheet answers has also presented the conductor's radius calculations by multiplying the diameter by 0.4885 instead of dividing by 2, which gives the same result. Additionally, the lab sheet answers has presented the equivalent geometric mean radius and capacitance per phase per kilometer to 4 decimal places, while the manual calculation has presented these values to 3 decimal places. In exercise 3, it seems the both methods were used to determine the inductance and capacitance per phase kilometer for the of 345 kV double circuit 3-phase transport line. The lab sheet answers used MATLAB software to solve problem, while the manual calculations utilized formula and equations to arrive the solutions. Both methods provided the same results for the inductance and capacitance values, which suggested they are equal accurate. So the lab sheet answer is for using MATLAB manual solutions. So let's start for the first one. This is first exercise. And this is the second exercise. So and exercise. So let's see in the manual solutions. Solution. This first exercise same as manual calculation. Same. And also manual solutions and manual calculations are same. Second exercise and third exercise. So it means same results. We get both manual and calculation and manual solution. So let us back the conclusion. So the main findings and results of the information provided are the values of inductance and capacitance by unit length for the 3 different excesses. For the excess 1, the values are L is equal to 1.3802 mH/km divided km, and C is equal to 0.0083 UV divided km. For the excess 2, the values L are is equal to 1.0588 mH divided km, and C 0.010 UF divided km. For the excess 3, the value is L is equal to 0.4914 mH divided km, and the C, while C is 0.0232 UF km. In addition, there are also manual calculated values for XS1 and XS2 and XS3. The values obtained for a manual calculations are slightly different from the given values in XS1 and 3. Furthermore, in the 3 exercises, it appears that both lab sheet answer and manual calculation have arrived at the same value for the inductance and capacitance per phase kilometer of the given transmission line. That's all. Thank you.